Hi, I'm Ahmed Daud, and in this session, we are going to explore the attributes and methods provided by Scikit Logistic Regression class. So, in the last session, we have discussed parameters, and about 2 to 3 sessions we did on the parameters, and we have explored very well all the parameters. Okay, and the parameters that are really important we have discussed also in detail. Okay, so before going to start today's session, I want to tell you by setting the parameter values is actually mean that you are setting the structure of your model. What type of model you want. Okay, if you set some parameter value and penalty, let's say you set the penalty is equal to L2. It means you want such type of logistic regression in which during training the cost function that will be used should have some L2 penalty should have some L2 penalty also with it. Okay. Or in other words, you can say this model will penalize its parameters, its weights, its coefficients by L2 penalty. Okay. So parameter value, by changing the parameter values, you can change the structure of your model. And if as your structure of your model will change, that's why your maybe some computations will decrease or increase. Maybe your score will increase or decrease. Okay, and these factors will can be affected by the changing of parameter values. So today's session is very simple. We will discuss just attributes. When we have trained our model, what we can get from the attribute by using that as sklearn, what we can find or what sklearn give us the facilities that we can use. Let's say attributes here. Just 1, 2, 3, 4, 5, 6 parameters we attributes. Sorry, we have. So first, we can find out after the we can find out what number of classes we have in our data set. We can find out coefficient. What is the value of coefficient that during training the model has obtained best fit uh, coefficient, best fit coefficient. What is the intercept value it has obtained, and features in how many number of features are uh, like involved or how many number of independent features used here in this during this model. Feature name, what is the feature name that we have used. Let's say in the case of age and about insurance, age is independent feature, about is dependent feature. So age, if we will use feature names in this attribute, it will print the name of age. And iteration. Okay, how many number of iterations the model has done during its training process? We can do this on the Jupyter notebook so that you can get more precise idea. And don't worry about the parameters. I have not done the code for these parameter values just because there can be multiple combinations and you can play with yourself by passing different values to different parameters, and you can test the which type of model you are getting, which type of scores you are getting. Okay, so each parameter has some different values. Anyhow, so this is the code, and in that code, I also have code the this is the just extension of the same code that we have used during when we are learning why we can't use linear regression for the classification problem, and I have discussed that two major problems of linear regression, and I have taken the screenshot from that code, and the same code I am using here, and in the end I will discuss the attributes, how we can use attributes. Okay, so it's very simple code. You know about the linear regression, so I will quickly go through that. Okay, so some of the important libraries, as always, we usually use NumPy, Pandas, Matplotlib, Seaborn, warning to ignore the warnings, and linear regression here I am importing. So this dataset insurance data.csv, this dataset in which there are 25 data points I am here using, and independent variable age, dependent variable age is powered insurance. If we will draw the scatter plot of that, here you can see this is the scatter plot. There are 30 number of ones and 12 zeros in our target variable. I have just split into x and y. Here training of linear regression. So these are the predictions by linear regression, and I have just flattened used to make it in the one-dimensional array. Okay, now here you can see this is the model linear regression on the same scatter plot. Here I have copied my data originally that we have, and here I am adding at some location of 6 the value 92, just extreme value. Okay, and so that I can check the behavior of linear regression. Here this is the scatter the point that I have here added 92, and I have again separated my data set into x2 and y2 now, and here I have trained my linear regression on this x2 and y2, and here in the x2 there is a extreme value which is 92. And here you can see this is the model as we have obtained, and you have clear difference that model has is a little bit rotated in the clockwise direction. Okay, and here you can see the difference between both of them. Okay, so this is just the code that we have discussed in the last sessions of why we can't use linear regression, and why if we convert our linear regression into some logistic regression. So the same code I have used it there. Screenshots I have shown in you the notepad. Okay, here logistic regression we can import directly from the sklearn.linear model, as we have imported our linear regression. So here I am again fitting my the x and y by using logistic regression class, and these are the predictions by the model. Okay, so if you are interested in to see the probabilities, okay, as I have told you, uh, the probabilities, if I will show you here, the model's equation of logistic regression has p cap 1 over 1 plus e raised to power minus mx plus c. Okay, this is the model's equation, and it will give you a value between 0 to 1. Okay, so if p cap is 0. Let's say 7, it means that there is a 70% chance that the given sample is belong to the one class. Okay, so if I will use 1 minus p cap, it will be 0.3, and this is for the class 1, and in the opposite way I can get for the class 0. Okay, if there is a chance of 70% chance of getting class 1, then there is 30% chance of getting class 0. It's simple. And in the case of logit, you have also used seen the odds ratio. Okay, probability of getting 1 divided by probability of getting 0. Okay, so here when you will use the probability, if I will show you here, when you will use the predict probability, here in the functions you will see that in the methods of, yeah, here predict probability, it give you probability estimates. Okay, against each sample. Here against one sample number 1, let's say if I will print here, this is x. Okay, keep in mind here I have not used any parameter value. I am using the by default values. Okay, and what are my default values here? If you want to see, you can use the method dot get underscore parameters. Here you can see these parameter values I have used here. Okay, as I have not mentioned any value, so these default values I have used here. Uh, C is equal 1 in class fit none, dual is false, fit and set true, intercept scaling 1, L1 ratio none, maximum iteration 100, multi-class and so on. Solver LBFGS tolerance 0.0001. Okay, okay. So come back here. We are discussing predict probability, and here I have passed the X, the same age that I have used during my training. So against 22, it is here giving me two values here. Okay, so two values, and the first value is for the class 1 0, probability for the class 0, and here the probability in the case of class 1. Here you can see the probability for the class 0 is 0.99. Okay, it's in the form of 10 raised to power minus 1. So if you will see for if I will print here instead of this, yeah, here you can see. So this is the probability of class 0. Here it is saying that 99% probability of class 0. If again, if I want to, can make it in this way, 0, comma 0. Yeah, 99 or 0.99. Uh, it's a probability that 99% chance that this sample belongs to class 0, this 20, where the age is 22. 99% chance that this sample belongs to the class 0. And how many number of chances for the class 1? Yeah, 0.0002%, or in other words, when you will multiply by 100, it will become, let's say, 100. Yeah, 0.02% chances that this sample, when age is 22, is belong to the class 1. Okay, so this is the value. It's exactly the same. This is, if I will remove this is giving the exact the same score that the p cap is giving. Okay, and this is 1 minus p cap. Okay, here I will make a comment. It's a 1 minus p cap, and this is exactly the p that we have. Okay, so in this way you can also see the probabilities by using predict prob method, okay, provided by sklearn. So if I will use here, I am interested in just the probabilities of class 1, and I want to draw my graph, so I can do in this way all the rows. Just I am interested in the one column, so these are the probabilities of class 1 against each sample. Okay, so by using these probabilities, I will draw my graph here, and here you can say the logistic model has S-shaped model here, S-shaped curve here. Okay, so here in the case of when we have x2 and y2, our model, when we have trained on x2 y2, x2 in which we have extreme value, and again our model is not so much changed. Here we can see the difference. Yeah, our model is not changed as much, not changed really here, as or there is no clear difference in the structure of the curve of our model. But in the case of linear regression, you have seen a clear difference between both, in the case of no extreme value and in the case of extreme value. Okay, so in this way, you got an idea that logistic regression is not much affected by the extreme values because of the nature of the logistic function. Okay, that we have used, or that usually used in the logistic regression. Okay, so now come back that we are discussing this. First, we have started from the attributes. Now we will explore all attributes one by one. And okay, now I'm going to train my model. Here I have mentioned the penalty is equal to L1, and the solver is equal. Let's say here I will make the solver as a GM. Okay, so here I am fitting my x and y, and this is the score. Okay, score method you can use for the case to check the accuracy of your model score, and you know how score actually works. Let's say I will also give you an idea of score. Mm, let's say this is the original true values, and here just we have five values like 0, 0, 0, 1, 0, and these are our predictions. Okay, predictions that we have obtained, that our model has predicted. Okay, these are not the probabilities; these are the actual predictions. Let's say 0, 0, 1, 0. Okay, so how many number of times our model has correctly classified? This time, one, two, no, true, true. Like out of five, four times it has correctly classified. So this will be, if you will use 0.8, or you can say 80% score. This is the score. How score is calculated here? Okay, this score method. Okay, so this is the score here I am using. So when you will run that, sorry, here in the case of the previous score was the case of linear. Here, if you will see, in the case of linear, 1, the score is 100%, but in the case of SAGA, the score is very small, 0.52. And I have told you SAGA, it's a version of gradient descent in which it is not using all the data points in each iteration. It is just picking one data point in each iteration. Okay. So due to that nature of SAGA, it can give this score 0.52. But when you have very large data set, you will see that SAGA will take very less time as compared to other solvers during training. Okay, but here we have just 25 points, so we cannot see the clear difference. Okay. Um, okay, as I told you, in the each iteration, this SAGA use or just one instance to train the model, and by default our max if I will show you here again, classifier dot get parameters. Yeah, here you can see our we are using a maximum iteration 100. Okay, maybe due to less number of iteration, because by default it's max iteration 100. So maybe due to this parameter value, SAG is not giving a good score because it's not correctly or clearly you can say, or properly trained, because it is getting one data point in each iteration. So there is as maybe there is a chance that due to less number of iteration, it is not giving a good score. Here we can check it also. If we will increase our max iteration, maybe our score will change here. We'll make 1000 here. So now we will check. Yeah, here you can see our score become 96%. Okay, our score is increased. So as I told you, when you will change the parameter value, your structure of your model is changed. Okay, so you can play with these. Okay, so here your parameter value will be updated to from 100 to 1000. Here you can see. Anyhow, so predict probability, I have explained to you this method. So one more important thing I want to discuss here. There is some difference between attributes and methods. Attributes, that values are already calculated. Okay, so in the class, if you know about the concepts of OOP, object oriented programming, so you know very well about this, the difference between attributes and functions. Okay, during function, upon our requirement, our or upon the structure of function, it calculate, or sometimes simultaneously the people are using the name of methods and functions. These are the you can say these are the similar to each other, functions and methods. So here these methods during the methods or you can say function, it calculate the value upon our request. Okay, but in the case of attributes, values are already calculated in our class. So this is the difference between attributes and methods. Okay, yeah, these are the methods. So here this is predict proba, and when I have I you can say I have used that method, and I told you told to my model or my sklearn that I am interested in to see the probabilities against each class. Okay, as we have just two classes, class 0 and class 1, so that's why each instance, against each instance, it is giving just two probabilities. Okay, so we can use predict proba if we want to see the probabilities, or if we want to use for further use. Sometimes when we have to set the threshold, then we also use predict proba. Okay. So second, this is the predict log proba. It's also another method. Okay, we can discuss attributes and methods together, so that we have discussed fit method to train the model, get parameters. We have discussed predict to predict the values, predict probability. It gives you probability estimates. So we also have discussed score. It gives you the some score, mean accuracy on the given set, and I have told you how it calculates the score. I am using here the solver deep linear. Let's say it is giving 100% accuracy, and this is get parameters. So these are the probabilities. Let's say 0.86, 0.3752, and I was saying that this particular probability should give here, let's say minus 0.15. It is just a log of these probabilities, okay? Just the logarithm of these probabilities. And here, if I will pass the values, 0.860375 and it should give the same value here. Yeah, minus 1503867. Here you can see, okay? So it's nothing, just a logarithm of your probabilities. Predict log proba will give you, okay, predict log probability. Okay, it's just a logarithm of your probabilities. So next we can see, okay, classes. Okay, some arguments, attributes we should see. Okay, that this is just the model. Okay, so this is the S-shaped curve that we have obtained during our, when we have this model linear. We have that logistic regression, and solver is linear and penalty is alpha. Okay, so you can play with the parameter values. Each time you will get some different curve, some different probabilities. Okay, so due to some different because you are playing with the structure of your model. So anyhow, now we will discuss the attributes that we have really started, and we went towards the side of discussing methods. So here are classes, coefficient, intercept, and features, feature names, and iteration we will discuss here. So how many classes we have passed during our training of classifier? Two classes, 0 and 1. What is the coefficient value? Coefficient value, it's here I am saying about this one. Okay, so this one is a coefficient. This m is a coefficient, c is intercept. M is coefficient, c is intercept. Okay, so coefficient value is here 0.14 and intercept value is minus 0.20 here. How many features I have used in independent features during training of my model? Just one. And how many? What is the name of that feature? It's age. How many number of iterations performed during my training of model? Here we can see it's same, just 34. So sometimes these this number of iteration, this attribute is not giving you the same iteration that you have mentioned during the parameter value, just because your model is stopped before. Okay, it is giving you the number of iteration that performed during the training process. Okay, it is not the same number of iterations that you have mentioned in the parameter values. It is the practical number of iterations that actually how many number of iteration performed during the training process. Okay, so if in the case of, let's say in the case of SAGA, uh, 1000 iterations, and now it will give you an iteration 1000. Maybe in that case also it can give you some, let's say if you will decrease the tolerance, let's say 0.01, Okay, so your accuracy score will decrease here and your tolerance is 0.01. Now, in the parameter values, you have mentioned that your model can run up to 1,000 iterations, but your model is stopped before because of just tolerance. It meets the tolerance, or it reached to that criteria of 0.01. Okay, so in that case, your an iteration will tell you actual iterations performed during the training process. Yeah, just 8 iterations. After 8 iterations, you have reached the position of 0.01. Your error reached. Okay, so we can discuss tolerance and max iteration by considering a pseudocode. So, gradient descent works in that way. First, it randomly initialize parameters, then randomly initialize parameters, then calculate the partial derivatives of the cost function with respect to each parameter, then update the parameter, and then repeat that process. Okay, that repeat step 2 and 3. Okay, so in this way, gradient descent works. And our aim is to find out such type of parameters where our loss is minimum, our error is minimum. Okay, so in the same way, we will discuss in this way. First of all, we will randomly initialize our parameters like M and C, and then we will calculate the log loss. Like in the case of logistic regression, we have log loss. So M and according to these M and C, then we will start our loop. First, we will calculate our gradients. Okay, then we will update our parameters like these. Update our parameters with respect to some learning rate. Okay, so after updating parameters, we are here I am passing my j, which was the loss I have calculated before the loop, as a previous loss, previous j. Now I want to calculate my loss with respect to my updated parameters, with respect to my updated parameters. Okay, then I will calculate the difference between the previous loss and the recent loss. Okay, or I want to see how much decrease in loss is done by updating these parameters. Okay, how much loss is decreased in this iteration, this particular iteration. Now, if this decrease is loss is less than the tolerance, okay, less than tolerance by default, it's about 0.0001. Yeah, if our loss decrease in loss is less than or equal to that tolerance, then we will break the loop and our training will be complete here. Okay, our training will be done. No further this loop will run here. Now on the base of that condition, on the base of that condition, the loop can training will be complete or training will stop. And on the base of that max iteration, if our loop will has run that number of times that we have mentioned, okay, then our training will stop. Now you have seen that our training can stop in two ways. If the loop will reach to max iteration, and if our tolerance, if our decrease in error will reach to our specified tolerance. Okay, now I hope you got an idea about the tolerance and max iteration. Okay, so this is just a pseudocode to give you an idea. Actually, how you can ask that where is alpha or what is the learning rate, just to give you an idea how the process carried out. Okay, so and what exactly the meaning of tolerance, how tolerance can stop the training process. Okay, and what is max iteration, where max iteration is actually working. Okay, so any other thing, let's say here we will use another lib linear. Let's say it is giving 1. Okay, so again, parameter value is 1000 here. Okay, and these are just parameter values, but how many number of times the algorithm or the process algorithm has performed the iterations how many number of times. So if you are interested to see that, you can use that attribute. So it will give you, in the case of linear, it is in the 10, after 10 iterations, it reach to that stopping criteria. Maybe if you will increase that, let's say 0.401. So uh, the here you have this tolerance, but here your iterations will increase because your stopping criteria uh, is now is much smaller as before. Here you can see your number of iterations increased. Okay, you meet your stopping criteria after 31 iterations. Okay, so this is tolerance is actually that how much tolerance you can bear. Okay, so it usually used for the stopping criteria and iteration. Okay, so now the methods here. Uh, one important method is decision function. I will explain you in a while. Fit, we have discussed get parameters, set parameters. Okay, so we can use set parameter, specify, densify. Yeah, just four methods we have to discuss here. Okay, so before we can use, yeah, this is get parameters, and you can use here, let's say, set parameter. Okay, set parameters, and here you want to, yeah, like we'll pass a dictionary, and here let's say you want to set the parameter value max iteration, max iteration, let's say 50. Okay, so now you have set your parameter value and max iteration 50 and penalty L1, so linear tolerance 1 0 point tetra 0 1, it's already here. Now you will see your max iteration is 50. So now you in this way you can also set the parameter values here. But again, now your model is not trained. You have to again train your model according to these values. The previous values will be the different. Okay, you have actually set the parameter value here. Okay, now if you will, let's say this is classify one. Uh, in this case, if you fit your model, mm, previously it is giving. Okay, so we can decrease it to, let's say, 10 iteration. 10 iteration. Okay, so we have set the parameter value max iteration 10. Now if we will fit our model, now our model score is again it's 10. So if we will use here, let's say, we will update our solver also. Solver, we want to use SAGA. Let's say SAGA should also in the form of the string. Yeah, SAGA. So solver SAGA. Yeah, here you can say it's 0.52. Uh, if I will make it 1000, 10,000, yeah, it's become one. Okay, in this way you can also set the parameter value. But you know, when you have set your parameter value, your model has to again train on the data, because previous model has different parameter values. Okay, you are actually updating or setting the parameters values, then you have to again train your model. Okay, the previous model was trained on previous parameter values, or according to the previous parameter values, or your previous model has different structure. Okay, so set parameter value we have discussed here. Uh, Densifies and specify. So what is the difference between densify and sparsify methods? Okay, provided by Scikit Learn. So densify convert coefficient matrix to dense array format. Okay, and sparsify convert coefficient matrix to sparse format. Okay, so actually, there are two type of matrices that we usually discuss, and in numerical analysis or linear algebra we discuss that in more detail. Sparse matrix and dense matrix. Okay, sparse matrix in which we have more number of elements, or more number of elements we have zero elements. Okay, and a dense matrix in which number of elements, mostly number of elements are or mostly elements are non-zeros. Okay, so if you want to see your coefficient matrix in the form of dense format, okay, then you can use densify, and already our coefficients are in the form of, usually in the form of densify or dense format. Okay, if you want to see your coefficient matrix into sparse format, you can uh, call that method. Okay, so I will show you here. Let's say your previously your coefficient here. Okay, so if I will run here, let's say, okay, previously, or we have this, if I will run this in this way, okay, if I will run again that, now you will see. Okay, so your classified dot coefficient here is 0.14. Okay, so there is already just one element here, so that's why it is you cannot explore here very well regarding the other format. But anyhow, this is already in the dense format. Okay, so if you will run densify method, it will give you again the same array that you are getting in the classified dot coefficient. Okay, so when you will run the sparsify method, that's a sparsify method, then you will see that you will get a different format. Okay, sparse format. In sparsify means that we consider that our coefficient matrix will have a lot of zeros in it. Okay, a lot of zeros in it. Like in the case of lasso regression, there are a lot of zeros we were having. Okay, so in that say case, we just interested in the non-zero coefficients. Okay, so that's why we can also call the sparsify method, and it will give you, and here you can see the description, one cross one sparse matrix we have just one cross one sparse matrix of type numpy float 64, and there is just one stored element. There is one just one stored element, and which is here is not non-zero element. Okay, and at the zeroth position it is present here, 0.19. And you can also see here, if I will, this is two-dimensional array. Okay, and by first zero it will get this first dimensional array, and by the second index you can get this value. Okay, so this will print the indexes of non-zero coefficients. Okay, so if you will run this specify method, it will and then you will print your coefficients. It will only print the non-zero coefficients with the indexes. Okay, now again, if you will run densify, and here you will have coefficient, and you can here you can see coefficient, and if you will pass let's say 0 and again 0, you will see that you will get this value 0.14, and here you can say 0 0 at the 0 0 index. Okay, so here okay, so we sparse matrix, we cannot categorize that this is a sparse matrix. There is no strict definition regarding the proportion of zero value elements of for a matrix to qualify as a sparse. But a common criteria is that number of non-zero elements is roughly equal to number of rows or columns. Usually we don't call we don't call as a sparse matrix or a dense matrix. Instead, we are saying that this percentage of elements in our matrix are sparse, and this percentage of elements are dense. Uh, you can say dense elements. Okay, or in other words, you can say this matrix has 50 like this percentage of sparsity and this percent of density. Let's say we consider that A matrix in which we have three one-dimensional rows, and you can consider here nine elements that we have total. Okay, so out of nine elements, how many elements are non-zero? One, two, three, four, five elements are non-zero here. Okay, so here will be these are the five elements. Okay, so how many elements are zero? One, two, three, four elements are zero here. Okay, 44. So you can say this matrix has 44% sparsity. Here you can say this is 4. You can copy here. 44% this matrix has sparsity. Okay, because it has four zeros. And how many non-zero elements here? There is mm, 5 here. Here, if you will use 5 over 9, this percentage of elements are dense. Okay, so 55%, your matrix is 55% dense and 44% sparse. Okay, so if you want to see this matrix in the form of sparse matrix, as I told you, in the case of sparse matrix, like when we have more percentage of sparsity, then there will be sure that there will be a lot of zeros in our matrix. And if we are just interested in to see the non-zero elements, then we can, in the case of logistic regression, we can call sparsify method, and then we can see by printing the coefficients we can see the just non-zero elements. And here if you want to see these elements as non-zeros, because we have not like a multi-dimensional array, we just have one value, so that's why I have give I am giving you that example here. In that case, if you want to see the sparse format for that matrix, this is the dense format that we have here. And if we want to see the format, here I am using a CSR matrix method of scientific python.sparse. And if you will pass here A, here you can see it is giving you the description here, 3 cross 3 sparse matrix you have of type class numpy with 5 stored elements in compressed sparse. 5 elements are that you can say uh, non-zero elements here. Here you can see this 1, 2, 5, 3, 9, and all these are the indexes where at which position they are present actually. And CSR matrix means compressed sparse row matrix. Okay, this function you can use, but here you can get an idea what is meant by sparsity, sparsify and densify. If you want to see your coefficients uh, in the form of sparse format, then you can run that method and then you can print your coefficients. If you want to see in the form of dense method, then you can run that method and you can see in the form of if you will print your coefficients, you can see in the form of dense format. And by default already our coefficients are in the form of dense formats. This is really important densify function decision function. So this I want to tell you here. Mm, okay, so for the let's say usually we have our um, when we have discussed the logistic function, I have told you that t cap 1 over 1 plus e raised to power minus t. Okay. Now, if t is value, here you can say if t value is, this is t on the x-axis. On the x-axis, you have t. Okay. So, if your t is greater than 0, then your t cap is also greater than 0. And if t is less than 0, then your t cap is also less than 0. Understand? So the middle one, this position can also consider as a decision boundary. Like on the right of that 0.5, on the right of that line, if I will draw that line, yeah, this line. On the right side of that points, the points will have positive values. Okay, there will be some positives, and you can consider on that also a one class belongs to one class, because these are having value greater than 0.5. And on this side, you can consider as zero class, because they also have less than 0.5 values, and their inputs also negatives. Okay, so in this way, if you will write the equation of your model, let's say your model's equation was p cap 1 over 1 plus e raised to power minus mx plus c. Now, in the same way, mx plus c, if mx plus c is greater than 0, then your p cap will be greater than, uh, here it's not a 0, it's 0.5. If it is greater than 0, then p cap is greater than 5 and it's 0.5 in this way. Okay, so your p cap will be greater than 0.5. And if it is mx plus c is less than 0, then p cap will be less than 0.5. Okay, so in between 0.5 position, where your p cap is 0.5, we usually call as, let's say this is our model, and at this position we are getting 0.5, so this will become a decision boundary. Okay, so on this side, mx plus c will be positive. On this side of the decision boundary, mx plus c will be negative. Okay, so this can be considered as a boundary, and on this side, on the right side, we can say positives, and on the left side we can say negatives. In other words, we can say on this side there will be one class, on this side there will be zero class. Okay, so now what is the decision function? Decision function will give you the values of that you are passing to your logistic function. Okay, the values here, um, with respect to mx, let's say your age is 22. If you will pass a sample age is 22. Now, how your model will work in this way: p cap 1 over 1 plus e raised to power minus mx plus c, and here you also have m and c. In our case, what values we have for m and c? Let's say for the coefficient we have 0.19, and for the intercept, um, why it is 0.19 here? Um, so intensifying here 0.19, but here is 0.14. Okay, 0.19, intercept minus 6. Okay, so 0.19 we have here, 0.19 our coefficient, and minus 6.9 we have intercept. Okay, and 6.9 we have intercepted. So this will become, if m, sorry, in this way you can see, uh, your m is 0.19, your age is 22 plus minus 6.9. Okay, if this value probably less than 0, it will be less than 0. Okay, this will be less than 0. So if this value is less than 0, when you will pass that value to here, your probability will be less than 0.5. Okay, and more, and if your probability is less than 0.5, then this sample will be considered as a class 0. So here your bout insurance will be 0. In this way process is carried out. So when you will when we use decision function model, let's say we are using here mm, classifier. We have given the name to our model classifier 1. when you will use decision function method, it will print the values of mx plus c, these values, okay, against each sample. Against each sample, it will give you mx plus c values, okay. So if these values will be positive, then of course this will be considered as a one class, and if these values can be negative, this will be considered a negative class. So uh, anyhow, for the simplicity, you can say decision function will give you these values. Decision function will give you these values, mx plus c, okay. And you can also check it here. Let's say you have run here decision function, and before this I can print here, uh, print classifier one dot coefficient classifier dot intercept, and here will be classifier one, okay. You have these two values. Now your x is here, this is your x 22 25. When you will pass to that function, that method of scikit-learn classified dot decision function x. Now the first value against 22 you are getting minus 2.5. Against 22 you are getting minus 2.5, and it's the same as mx plus c. Here I will mention mx plus c. It's the same mx plus c, and you can also check it out. 0.19 into 22, which is our age, and plus, here in the brackets I will add minus 6.9. So it will be minus 2.72. So it is just because of we have given a different values here. These are not exactly same. If you will use this whole value here, yeah, and this whole value here, you will most probably you will get the almost equal answer. Yeah, minus 2.594981. Here you can see. Okay. Now this decision function will give you the values before passing to the logistic function. Okay, the value is like mx plus c, you can say. And if the value is negative, here this value is negative, it means your after passing to logistic function, the output will be less than 0.5. Okay, you can see also here your output will be less than 0.5. Let's say this is predict probability, and here I am interested in just the probability of class 1. Okay, so the probability for class 1, actually the p values, okay, p values here. Now here you can see this is less than 0.5, and it is negative, and where it is positive. So when you will pass some positive value to your logistic function, it will be greater than 0.5, 0.89. Okay, so okay, so I hope you got an idea about the decision function. It's really the simple. You are getting the values of mx plus c, and it's really you. I have given you. There are more some more explanation than we need here to discuss decision function method. Uh, this method, but it I am telling you here just to give you an idea. You can analyze um, your logistic regression from another view also, and this is also important when you will study, or you will have a look on the support vector machines. This concept is also used there. Okay, decision boundaries, the concept of decision boundaries. So here you can see here again, in this case, let's say I will draw here. In this way, you will get 0.5 value, at this position. Let's say we get 0.5 value at this position. I will at this position. Let's say mm, this position. Okay. So anyhow, it's again not this exactly the straight. Okay. So oh, here here you are passing the age. If you will pass the value of, let's say, if you will plot your graph against m into age plus c, then your decision boundary will be the middle one, and again your graph will pass in that way. Your S shape will be in this way. But here you are plotting against age, boat insurance versus age. So that's why it is just on the right side because your uh, age values are positive. So now this will become the decision boundary. This will become the decision boundary. Okay. Here you can see this is the decision boundary. Now points on the right side of on this side of uh, will be considered as a one class, and points on the left side of this decision boundary will be considered as a zero class. Okay, so I hope you got enough for today session. So we have discussed all regarding the SKLN provided by the logistic regression. Okay, so there are again a lot of detail again behind each parameter, behind each attribute, and behind each method. There are a lot of concepts involved, and you should also have a look on that documentation, the references also, and the most important concepts regarding each parameter I have told you explained here. And regarding if you want to go in more detail, you can refer the references that I've mentioned by sklearn. So I hope you have got enough for today. So for now, thank you.